Welcome back. We have a question here and it reads, a body of mass 12 kilograms rests on a smooth horizontal table. Two bodies of masses 2 kilograms and 6 kilograms hanging freely are attached to the 12 kilogram body by means of light, inextensible strings which pass over smooth pulleys fixed at the edges of the table. The strings are taut, determine the acceleration and the tension in the strings. Here we have a diagrammatic representation of what we have just read from the question. We have a 12 kilogram mass that is resting on a smooth horizontal table, and at the edges of the table we have pulleys. The masses, 2 kilogram mass and the 6 kilogram mass, are attached to the 12 kilogram mass by means of strings which pass over pulleys, as you can see. So in this system, we have two different strings. We have one here and one here. So which means that the tension in the strings could potentially be different. Now, let me call the tension that is here as T1, and the tension in the other string as T2. So this will be T2. What we need to understand here is, if this system is released from rest, if there has to be acceleration, then the 6 kilogram mass is going to accelerate downwards, while the 2 kilogram mass is going to accelerate upwards. This is going to be how motion will take place. So we can start solving the problems. Let's say, let the 6 kilogram mass be M1, the 2 kilogram mass be M2, and the 12 kilogram mass be M3. So this is M1, this is M2, and this is M3. For the 6 kilogram mass, which is M1, if this system is to accelerate, we've said that for the 6 kilogram mass, if it is to accelerate downwards, it means that its weight is greater than the tension in the string. So we can say that the weight is greater than the tension. So the net force will be weight minus tension is equal to mass times acceleration. We know that weight is equal to mass times gravity. In that case, it will be m1g minus the tension is T1 is equal to the mass will be m1 multiplied by A. So substituting the values for the 6 kilogram mass, we have m1 as 6 multiplied by 10 minus T1 is equal to 6 times A. So 6 times 10 is 60 minus T1 is equal to 6A. To find T1, we can say 60 minus 6A is equal to T1. Therefore, T1 is equal to 60 minus 6A. We can call this equation 1. Okay. Then let's consider for the 2 kilogram mass. For the 2 kilogram mass, which is M2, we said that it is going to accelerate upwards. So which means tension will be greater than the weight. So the net force will be tension minus weight is equal to mass times acceleration. But the tension there is T2. Okay? So T2 minus weight is equal to mass times gravity. In that case, it will be M2G is equal to M2A. So substituting the values, T2 minus the mass is 2 kilograms multiplied by gravity, which is 10, is equals to 2 times A. So T2 minus 2 times 10 is 20 is equal to 2A. To make T2 the subject of the formula, we're going to have T2 is equals to 2A plus 20. Or you can say T2 is equals to 20 plus 2A. It's the same thing. I just want to maintain a specific order, right? So let's call this equation 2. Okay? So let's consider for the 12 kilogram mass. For the 12 kilogram mass, it is going to accelerate this way towards the right, because what happens is the 6 kilogram mass is going to accelerate downwards, the 2 kilogram mass is going to accelerate upwards, so the 12 kilogram mass has to move towards the right. So which means the two forces that are acting on the 12 kilogram mass to make it accelerate along the table are T1 and T2. So for it to move this way, that is for it to move towards the right, tension 1 must be greater than tension 2. Okay. For the 12 kilogram mass, which is M3, we said that tension 1 must be greater than tension 2. In that case, the net force will be tension 1 minus tension 2 is equal to mass times acceleration. So in that case, tension 1 minus tension 2 is equal to M3A. So substituting the values, we're going to have T1 minus T2 is equal to M3 is 12 multiplied by A. So T1 minus T2 is equals to 12A. We can call this equation 3. So we already know that T1 is equals to 60 minus 6A. We know that T2 is equals to 20 plus 2A. We can substitute this in equation 3 to be able to find A. All right? So substituting equation 1 and 2 into equation 3. But what is equation 3? Is T1 minus T2 is equal to 12A. So for equation 1, T1 is 60 minus 6A. Then minus what is equation 2, 20 plus 2A. This is equal to 12A. So if we expand this, we're going to have 60 minus 6A minus 20 minus 2A is equal to 12A. Okay, so remember that minus times plus will be minus. So that is why we have minus 2A here. Moving on, we're going to have 60 minus 20 minus 6A minus 2A is equal to 12A. So 60 minus 20 is 40. Then minus 6a minus 2a is minus 8a is equal to 12a. So we're going to have 40 is equal to 12a plus 8a. If we collect like terms, 40 is equal to 12 plus 8 is 20a. So by dividing both sides by 20, a is equal to 2 meters per second squared. That is the common acceleration when the system is released from rest. So to be able to find the tension in the string, we can say using equation 1, which is tension 1 is equals to 60 minus 6a, then substituting the values, we're going to have tension 1 is equals to 60 minus 6 into the acceleration is 2. Tension 1 is equal to 60 minus 12. Tension 1 is equal to 60 minus 12 is 48 newtons. Using equation 2, what is equation 2? Equation 2 is tension is equal to 20 plus 2a. Tension 2 is equal to 20 plus 2a. So tension 2 is equals to 20 plus 2 into the acceleration is 2. Tension 2 is equal to 20 plus 2 times 2 is 4. So tension 2 is equals to 24 newtons. That answers the question. So we have the body accelerating at 2 meters per second squared. The tension in the string between the 12 kilogram mass and the 6 kilogram mass, which is T1, is 48 newtons, and the tension in the string between the 12 kilogram mass and the 2 kilogram mass is 24 newtons. Thank you very much for your attention. If this is the first time visiting our channel, please subscribe, share, and like our videos.